A non-standard galvanic cell is constructed based on the following half reactions at 25 degrees Celsius. Non-standard, where the cadmium ion concentration is 0.010 molar and the lead-2 ion concentration is 0.100 molar. Under these conditions, would the cell potential be greater than, less than, or equal to the cell potential under standard conditions? Justify your answer. In addition to your answer, consider calculating cell potential for the galvanic cell using the Nernst equation. Alright, let's just forget everything we've read and just come up with what the standard cell potential would be first. As I look at my two reduction half reactions, the thing that's most likely to be reduced is the one that's more positive, in this case, the lead-2. Boom, easy enough, just copy it straight down. We also know that the cadmium is more likely to be oxidized. Boom. Again, be careful with your oxidation half reaction. Although you're keeping the numerical value, you are changing the sign of that potential. Alright, let's add these together, come up with our cell potential by summing together our two values, our reduction and oxidation potential, which gets us to positive 0.27 volts. Now that we know the standard cell potential, let's calculate what the potential would be under these non-standard conditions. To do that, we use the Nernst equation. At 25 degrees Celsius, the Nernst equation simplifies to 0.0592 over the number of moles of electrons transferred. In this case, 2 moles of electrons, times the log of Q. Now, we know the standard cell potential is positive 0.27 volts. As we think about our value for Q, our reactant ion is lead-2, our product ion is cadmium. Our Q value is equal to product concentrations over reactant concentrations. So 0.010 over 0.100. All right, let's calculator this up. First thing I'm going to do is I'm going to take the log of 0.010 over 0.100. Oh, that was easy enough. Who needs a calculator? We're going to multiply that by 0.0592. Our cell potential under these non-standard conditions is going to be positive 0.27 volts minus a negative 0.0296 volts. So 0.27 minus second answer. Enter. Cell potential under non-standard conditions, positive 0.30 volts. Boom. Okay, now before we go, I want to talk about how you're going to actually answer this question on the test. If you don't have the Nernst equation, what are you supposed to do? Well, one, you can memorize Nernst equation, problem solved. But two, if the Nernst equation is something that confuses you, all you have to do is focus on the value of Q, and you can still get full credit. Notice that our Q value is less than 1. So instead of doing the math to come up with the numerical value to help you answer this question, you can instead explain in terms of the reaction quotient Q. So we can say E cell will be greater than E naught cell, period. Under these non-standard conditions, there is a greater concentration of reactant than products, which results in a Q value less than 1. A Q value less than 1 provides a more thermodynamically favored condition, resulting in an increased voltage. Boom. So if you're concerned about memorizing the Nernst equation and you want to just come back to and understand it in terms of the reaction quotient Q, totally fine. That's all you need to do for the test. Done.